So we are going to discuss the cause of magnetism in lecture 10. What is the cause of magnetism? Due to the motion of the electron, we know when a charged particle is in motion, then it produces magnetism. Then how electron produces magnetism in an atom? And due to the magnetism of the electron, when many electrons in an atom, then they will produce a total magnetism. And this due to the this magnetism, when many atoms form a crystal, then in total they will produce a magnetism. In this way we find magnetism in the substance. So now my dear students, now I am going to show you a video clip of lecture 10. So I think you will get the clear idea of this lecture. First one is that what is the cause of the or origin of the magnetism in an atom. So I am going to show you how the motion of the electron, orbital motion of the electron and spin of electron produces magnetism in an atom. I think you see how the electrons are moving around the nucleus, orbital motion, and if more than one electron in an atom, then what will happen? I will show you. Okay, my dear students, now I am going to discuss lecture number 10. We are going to discuss lecture number 10. In this lecture, mainly I discuss the cause of magnetism in a substance. I mean, how electron produces magnetism in an atom. You know, electron moves around the nucleus in an atom. There are two types of motion. Number one, angular orbital motion and spin motion. Okay, so when electron is in motion, electron is a charged particle. So when electron is in motion, then it will create a magnetic field. So two magnetic fields are produced due to different types of motion, angular motion and spin motion. So you see, in an atom, here is the nucleus and here is the electron. So when electrons moving around the nucleus in the orbit, then it produces orbital. Then due to the orbital motion, it produces a magnetic field. And how much will be the magnetic field? Charge of an electron is E. Let its angular speed is omega, and linear velocity is v. Let it takes time t to complete a oscillation. So we know when a charge is in motion in a circular path or an orbit, then it produces a magnetic field B. So magnetic field produced by an electron due to orbital motion equals to mu naught I by 2r, where r is the radius of the orbit. So mu naught I by 2r. Then again I equals to e by t. Now the velocity of the electron is v. So what is the total distance? Total distance is 2 pi r. Total distance by time equals to velocity. That's why v equals to twice pi r by v. So v twice pi r by v. It is ev by 2 pi r. Is the I current produced due to the motion of the electron in the orbit. Therefore, how much magnetic field is produced? E is equals to mu naught I is EV divided by, here is the 2R and EV by 2 pi R. You are still the fact. So I is EV by 2 pi R and mu naught by 2R. So how much we get? E equals to mu naught EV by 4 pi R square. So we get how much magnetic field is produced? Mu naught EV by 4 pi R square is the magnetic field produced due to the orbital motion of the electron. Okay. Again, we have to find due to the motion of the electron, there is the angular momentum is produced. So angular motion of the electron, there is a magnetic field is produced. We are going to find it. So now again, magnetic moment due to angular motion of the electron. Sorry. So now again, we are going to find the magnetic moment due to motion of the electron. Magnetic moment due to motion of electron. Magnetic moment, M equals to I into A. Now I equals to E by T. T is the angular velocity is omega. Omega equals to twice pi by T. So T equals to twice pi by omega. So E by twice pi by omega. Then E omega by twice pi. And A equals to pi R square. So M equals to E omega by twice pi into pi R square. So E omega R square by 2. This is the magnetic moment. This is the magnetic moment. Now angular momentum of the electron. Angular momentum of the electron. Angular momentum of the electron. L equals to what? Angular momentum of the electron. How much is the angular momentum? M omega R square. M omega R square. Mass of the electron is M. M omega R square, where M is the mass of the electron. M mass of electron. mass of electron. So omega r square is equal to, therefore omega r square equals to L by M. So magnetic moment in magnetic moment due to angular motion, E by 2 L by M. E by 2 L by M. Here charge of the electron is negative. That's why ML, that's why magnetic moment ML equals to minus E L by twice M. Is the angular moment, magnetic moment of the electron. So we can write it. It's a vector term. That's why we write in L vector magnetic moment, angular magnetic moment, E L by 2M. Angular magnetic moment, and spin magnetic moment, MS. Spin magnetic moment will be E by 2 E by M S. S is the spin magnetic moment minus E by M S. Where is the spin magnetic moment. Therefore, total magnetic moment of an electron is ML plus MS. It is minus E by M L plus S. Angular momentum plus spin. Okay, spin of the electron is the total magnetic moment. So in this way we get the total magnetic moment produced by an electron in an atom. And this is the cause of why we get magnetism in magnetic substance. Okay, this is the cause why we get magnetism in the magnetic substance. This magnetic moment is produced in an atom. So many atoms in a crystal. So all of these together, they will produce the total magnetism in the crystal. So I think you got all the points in this lecture, how magnetism is produced in an atom. Okay, we got how much magnetism is produced. Due to motion of an electron is mu naught by 4 pi eV by r square. Okay, here I can show you the direction. I can show you also the direction of the magnetic moment. I can show you the direction of the magnetic moment, flow of current, magnetic moment, and angular momentum. In this direction, angular momentum, magnetic moment, downward direction, magnetic moment, flow of the current. Flow of the current like this. So charge of electron is E. Omega is the angular speed, V is the linear speed or linear velocity. That's why we get magnetic moment of an electron is the sum of the angular magnetic moment plus spin magnetic moment. Okay. Okay, for this I will show you a small video clip related with this, so it will be more clear to you. Okay, so thank you so much watching my lecture, and if you have any more question, you can write in the email address that is written in the left side of the board. You see TSZ73_UDDIN, and if you have any question, you can email to me. We'll discuss mathematical problem after when the chapter is finished. Okay, I think lot of things you learned today, and you must practice, and you must go through in detail of this topic, so that everything will be very clear to you. So here the symbols that I used, I don't write the name of the symbols because it will take so much time. That's why I'm going to finish it. So next time we'll see again. Allah Hafiz.